Okie dokie.
Cool. Define and use kinematic terms. Solve problems involving varying motion over time. First thing first. Anyone heard of kinematics or kinematic terms before? Kinetic. So moving. Yeah. Right. So if you have kinesthesia or any of those sorts of things, so K-I-N-E is Greek or Latin. I think it's correct. Greek prefix just meaning motion of some description, depending on the context. Cool. So we're dealing with things to do with motion. Okay. Unsurprisingly, in order to have motion, you need time, right? Because if you have motion with no time, I don't know what that is, but it's really difficult to think about. So we need motion and time. Okay. So we're going to have a whole lot of words that we're going to need to get rather clear, so that we can actually use them properly and not confuse ourselves immensely. Any ideas on what sort of words might be involved here? Yep.
Acceleration.
Acceleration would be one of them. Just down here. Okay, fine. Acceleration is good. Any other ideas? Take it. Time. I'm going to leave off time, simply because if we try to define time, we're going to very quickly run into some technical problems. We're going to leave time as just meaning time in the usual sense. Yep.
Displacement.
Displacement, yep. Yep.
Velocity.
Velocity, yep.
Direction.
Direction's good as well, actually. I didn't even think of that one. 8. Might need to move this down later. Okay, fine.
Speed.
Speed, yep.
Point.
Point. Yeah, it is a special case of a certain other word. Or, well, it's just a different word for it.
Position.
Position. Cool. There's one more starting with D in here. And this is, okay, I think.
Distance.
Distance, yep. And then this. Yeah, sorry.
Positive and negative.
No, but
You have negative also.
that's not the best spacing. Let's just move that down a little bit. Cool. All right. Those are the ones that we can think of. I don't think we're missing anything. Okay. A point or a position. What's a point or a position?
Coordinate.
Right, a set of coordinates. Right, that's all a position is. I'm just going to write coordinates. The coordinates. Cool. Out of curiosity, how many coordinates?
One.
One?
Oh, two.
Two?
Oh, three. Could be.
Okay, so it could be a whole bunch. Right? At least one.
Yeah.
Right? But you're usually going to have at least two. What two would you usually have?
The one.
Okay, y and x would make sense, save for one slight problem. We said that we're dealing with motion. What else do we need?
Oh, Z, which is T, which is time.
Right, you need t, time. Right, so you usually need at least one spatial one and at least one temporal. So one for space, one for time. Typically, what letters would you give those?
T and
T for time and
Y is what? S for space.
if you're just giving one dimension of space, x. Right, because it's the first one. X, Y, Z is typically for you 3 dimensions, so you usually start with x, and time is going to be t. You can have x, y, t, or rather t, x, y, and you can have t, x, y, z. Right? And if you want to go into hypergeometries, you can go into a whole bunch of other things where you've got w's and a whole bunch of other stuff. But we're just going to stick with, typically, t, x. Okay, okay. Direction. What's direction? This will be interesting to see if we can actually get a definition for this. What's a direction? North, south, east, west would be examples of directions, but we want a slightly more general definition if we can manage it.
The way something's going.
The way something is going. Forward would be another example. This gets a little bit fiddly. All we're going to say is,
Take it was in decision time.
well, actually, let's just plus minus.
Position is going.
Plus minus on or each axis. Right. So a direction, all it does is gives a plus and a minus to your axes. Right. So you have a forward direction in time and a backwards direction in time. Can you pick which way that is? Can you pick which way to go through time? No. Okay. Can you pick which way to go through an x-axis?
Yeah.
Yeah, right. You could arbitrarily go, well, I'm going to decide this is left and this is right. Or you could say, well, okay, right is going to be positive, left is negative, or you could just choose the other way around. Doesn't actually change anything physically. Time, however, seems to have a preferential flow. Entropy and all the rest of it, but we don't really care about that. Okay, distance. What's distance?
Speed of time.
Speed of time.
Speed over time.
Oh, speed over time. Oh, okay. Speed over time?
Time
Speed multiplied by time would be distance in that sense. But then we're using speed to define distance, which seems a little bit problematic.
the measurement
A measurement of
how far they go.
how far they've travelled. Do they have to have travelled it?
Measurement of length.
Measurement of length, yeah, okay.
Yes.
Right, measurement of space, okay. So, the length between what?
2 points.
Right,
But that can be a very broad statement.
yes it can be.
So would that be correct though? I mean, it is, but it can also mean other things.
There's what's called a space-time interval, right, which can be considered a distance as well, which has a lot more interesting, it doesn't work the way that you'd expect it to work. So there's all sorts of things that you can think of as a distance, but then it doesn't follow your normal Euclidean geometries. But anyway, it doesn't matter particularly. We're just putting up some words so that we can talk about this without getting lost in the details too much. Cool, all right. Displacement.
Where they ended up last.
Where they ended up last. Where they ended up last?
When they ended up last.
No. Okay. So is displacement a point? Because that's where they ended up.
It's not a specific point. It's where they ended up.
Where they ended up. But that's still a point. Is displacement a point?
Yeah, but it's like not a specific. It's not like two. It's not
Looking from where they started to where they finished, and then the final result minus the
Right.
starting result. The difference between finish and start finish. Starting point and end point.
Let's just say 2 points, which would be the start.
The final result.
So end minus start.
So
So, do we have a problem here? Potentially.
Yes.
What's that?
Well, the length between 2 points is the same as the difference between the 2 points.
Okay. So, do we need to make some sort of adjustment? Or are these things the same?
No.
Okay.
So displacement is like, it doesn't have to be positive, minus, negative, it doesn't have to be negative and positive.
Okay, good observation.
Whereas distance has to.
Can be positive or negative. Okay. Distance is always
Always positive.
always positive, right? Okay. Well, let's fiddle with this definition for a second. Length of the curve would be one way of writing it, but let's try and make this a bit better for 11. Um, 22. Of yeah. Okay, so the length of a path connecting these 2 points. So the length between 2 points of the path, of a path that connects them. Okay. Oops, wrong color. Cool, can this be positive or negative?
Positive.
Always positive, right? Beautiful. Okay. Are we happy with the difference between distance and displacement? Maybe, maybe not. Okay. If I walk from this end of the board to this end of the board, let's say that's what, 3 meters or something, roughly? Maybe 4? Maybe 4, sorry. Cool. What's the distance I've travelled?
4 meters. 3 meters.
About 3 or 4 meters, whichever number we pick. Okay, great. What's my displacement?
Negative.
Is it?
4
Why?
meters.
Because you walk that way, you walk negatively and you walk positively.
I haven't gone one direction so far.
Well,
So
Displacement is
from
4
there
meters.
over to here. So my displacement could be either positive 3 or negative 3, depending on which way I define my directions to be. Right? But if I define this way to be positive,
they will be positive.
then it'd be positive 3, and they'd be the same.
Oh,
But if I define positive to be that way, well now they're
Negative 3.
one's positive and one's negative, right? Okay. What if I do the trick that I just did, and then go to here, and for simplicity we'll say that's 4 meters. Okay, what's my distance
2
traveled?
meters.
6 meters.
6.
6 meters, sorry.
What's my displacement?
10 meters.
2.
2, right? And potentially positive or negative, just depending on which way I define it. Okay, fine. Cool, and if I keep my trip going to here, my distance
Is
8 meters.
and my displacement,
0.
beautiful. Okay, think about that. Alright, this doesn't count as part of the trip now. Speed. How do we define speed?
The rate at which something is travelling.
The rate at which, rate's a good word, rate at which,
An entity is travelling, an object is travelling.
okay, an entity is travelling, we're using a new word. Can we use one of the other ones?
The rate at which,
position.
Position does what?
is a specific.
Someone said it?
I think
What?
position. What was the question?
The rate at which position is
It's travel changing.
changing. That's the word I'm looking for. Which,
Regardless of direction.
okay, so we need to clarify.
Oh,
with you.
velocity is regardless of direction.
Okay, so this one's very.
So basically, velocity is speed with direction, or speed is like speed, velocity without direction.
Changes. Alright, I've got a problem because I've defined 2 different words the same, so what's the difference?
Speed is regardless of direction.
Okay. In other words, always positive.
No.
Why'd you put dot points there?
Because I'm going to come back to,
They're more like hyphens.
yeah, they're like subbits. Anyway, we'll come back to fill in those specifics in a second. Cool. So, let's say for argument's sake, this is 4 meters long. I go from here, 1, 2, right? What's my speed?
2 kilometers per...
Kilometers.
Oh, sorry, 2
Jeez,
meters
that
per
was
second.
impressive.
Sorry, 2 meters per second.
Right, 2 meters per second, right? Because I travelled 4 meters in 2 seconds, right?
He's
So,
actually an athlete.
yeah.
2 kilometers per second.
So, super basic. It's some distance over time. Cool. Okay. Fine. What's my velocity?
2 meters per second.
2 meters per second potentially, or
Or
Negative 2 meters.
could be negative 2 meters per second. Why?
Because negative, positive, or negative.
Right, I could have defined that way as positive, in which case I travelled in a negative direction, therefore I must be going at a negative velocity. Cool, beautiful. So, that one's just displacement. Oh, sorry, not
Distance.
Get it away. That one's distance over time, so velocity is displacement over time. Now, there's a slight problem with that, which I don't want to get into yet. Sorry, those are the hyphens. Okay, acceleration. What's acceleration?
acceleration is
Rate of rate, speed increases.
rate.
Right.
Man, you stole the word straight out of my mouth.
Ah, sorry, TJ.
Right.
I just didn't want to be sitting here for 5 minutes, that's all.
Now, is it the rate at which speed changes or the rate at which velocity changes?
Velocity,
Velocity.
because acceleration can be positive or negative.
There's a word that defines the rate that speed changes.
Not that I'm aware of. There probably is some specific thing that gets into that. I haven't ever come across it. I've only ever seen it in math notation, which is almost always useless information. Yeah. Well, no, you could. Yeah, it doesn't matter. Okay. Beautiful. So that looks pretty good. Obviously, I've got these hyphens here for a reason. If I said, okay, there's 2 different kinds of speed. These are going to be the same ideas, right, for each. If I wanted to know the speed of, okay, let's say, don't start yet. Okay, this is the start. Right, if I go like that, and let's say that took 2 seconds overall.
Average.
Average speed.
Okay, average speed is one thing. So, yeah, we'll go purple. Okay, average is one version. What's the other one?
Average.
Direct speed.
Sorry, what was that?
Instantaneous.
Instantaneous. That's right.
Yeah, there you go.
Spell it right. Okay. And we're going to have it bothered. Cool. In fact, I'll write this as ABG. Just to save everyone a little bit of space. Good. Okay. Alright, so we've got 2 different kinds. Okay. How do I calculate an average?
It's the x over time. So x being speed.
Okay. Almost. Change in x.
Yeah.
Over change in time. Go.
Yes.
Similar story with this. Now, I've just written the same thing twice. Is that a problem?
Yeah.
Yeah. What by default has to happen with speed?
Change to an S.
Change to it.
That has to be positive.
Right, it has to be positive. How do I put that on a formula? Because if it's already positive, it's fine.
Times -1.
But then if it was positive, then you'd make it negative.
Square.
Square. Yeah, sure.
That would actually work. You could square it and then square root it again. But then
Then that
whenever you
positive
take the square root,
That's positive or negative.
right, you have to put positive negative on the front usually anyway, so you potentially created more problems for yourself than helped. But you could do that. There's an easier way.
To the power of what?
Seen those symbols or no? No? Okay. That's called an absolute or a modulus. All it does, take the value. If it's negative, ignore the negative.
Oh.
That's it. That's all it does. So it just means take the positive version of this. If it's already positive, leave it alone. If it's negative, get rid of the negative. Q. Alright. Average velocity, however, can be positive or negative, so we just leave him alone. Cool. How do I get average acceleration?
It's the same thing.
The exact same thing?
No,
Oh,
it can be
yeah.
positive or negative.
Initial speed.
Bollocks.
Speed,
Velocity.
velocity, right? Specifically velocity, so we've got change in velocity over change in time. Beautiful. Okay, so that's how we get the average ones. How do you get an instantaneous one?
The derivative of x.
Derivatives, right? Because an instantaneous rate of change, right, which might be nonsensical in reality, but doesn't matter, we're only in math land. How do I write a derivative for this?
Dx over dz.
The derivative of x with respect to time. Cool. We're going to take the absolute of that, this one, and derivative of x with respect to time. So, beautiful. That's good. I need to check because I can't get down that way. Cool. Well, this is interesting because delta V, I like this. Velocity is another one. Where do I put this? There, well, now I don't really want to call this S, so maybe I should avoid that. No, I'll change that instead. Anyway, I'll make this point first. Okay, this is the change in velocity over the change in time. Okay, well, if I think about this for a second, hang on. The change in velocity, the velocity is this. So I can think of this as the change in position over the change in time over change in time. Now that's getting a bit chunky. Right, so the change in velocity, because that is velocity, over the change in time.
That's just say velocity.
Right, yeah, so change in velocity over change in time, but we know that velocity is just the same as change in position over change in time. So this is also equivalent. That's getting a bit chunky, right? So obviously we would prefer to use this wherever we can. Okay, from the same argument, we could say the derivative of velocity, which is dx dt. Again, this is starting to get a bit chunky.
You could just say it's the derivative of instantaneous speed
Derivative of velocity over derivative of time. Yeah, which is equivalent to that because d is just that. This notation very quickly turns into a lot of fractions, just like this one sort of did. So instead, we say the derivative, the second derivative with respect to x with respect to time twice. So the notation gets a little bit weird there. So this says derive twice this thing with respect to this thing twice.
So you derive x twice.
Right. Cool, so you derive the position once, you get velocity. Derive it again, you get acceleration.
Okay.
All good? Yep. Alright. Now, using all these words in math is like actually writing them down. It takes a lot of time. We don't want to do that. So we'll work from the bottom up and see if we can't come up with something. Would you like to write the entire word acceleration? What would you like to write instead?
A.
A. A makes a lot of sense. Cool. For velocity, what would you like to write?
B.
B. For speed, what would you like to write?
S.
Okay, S is what you'd like to write, yeah?
Maybe.
But S is not the answer.
S is not the answer. Okay. Let's go to, now, for a point, how do you write a point? Right, you go something, 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 something for however many coordinates you have. Right? Beautiful. Sometimes this thing will be called like a capital letter like A or something. Cool. So you can describe, okay, I want the point A, and A has the coordinates, whatever, whatever. Right? It'll be a capital. At least it should be. Cool. Direction. What do you use for directions?
North, south, east.
North, south, east, west is what you use specifically if you're only looking at a two-dimensional plane and you're not considering time.
North, square.
How do you draw your axes on a graph?
X, Y, Z.
Oh, X, Y, Z.
X, Y, Z. Okay. So usually, you're not going to like this in a second.
Is it X, Y, Z? And what's the next one? If it's like four-dimensional.
W usually. Use that going backwards. So you get a T and then it just becomes some, but a lot of the time you go X1, X2, X3, X4, X5 until you go as many as you want. So then you can have a 26-dimensional system if you want. This can vary depending on what you want it to represent. Typically you'll go through X, Y, Z's though, so we'll call them those. And then you'll have plus minuses on them, depending on which way you're going. The X, Y, Z is more of a dimension than a direction, but similar story. Cool. Distance, D would make sense, right? But D already turns up when we're talking about derivatives.
Capital.
Capital D makes sense then, right? So we'll
Is
call
it
it
the same
capital D.
with speed? Capital X?
Right, so a common thing is to do that, but we didn't use S already.
But S is going to be for displacement.
S is going to be for displacement. Because we've already used that. I looks too much like a 1 and you use it in complex numbers, so that's no good. S, okay, we'll use S. But then speed, oh, well this can be a capital S or something. This generally will not get used. Okay, because all speed is the absolute value of velocity. So velocity has more information, so this one you pretty much never use. Just as an aside, this will sometimes be U as well. Just if you've got multiple velocities, you'll have a U and a B usually. U is typically at time 0, but we don't have to worry about that so much. If you're doing physics, you'll get experience with that. Beautiful. Sorry, that's fine. Yeah, I think that's all good. Oh, we never defined. So with a position, if I'm talking just about one dimension, a position would normally be expressed with just x, if it's a specific point in space, or x, y, z, etc. So that's that. That's all good. Yeah, that's right. Another common thing for the point or position is it will start at P and then start going alphabetically from there. But sometimes it'll go backwards alphabetically as well, and sometimes they just pick, like they just go, all right, we're going to start at J for no reason.
Would it be called like average velocity, or would it be called like average rate of velocity?
But average velocity, yeah.
Would it just be called
Average rate of velocity is a different thing again.
Okay. So it would just be called average velocity and instantaneous velocity.
Yeah, they're prefixes. Or pre-words. Okay. That's supposed to be straight. And they're all supposed to be equally spaced. That's it. Good.
Yeah, if she just came around backwards.
So there are some paths between some points. So we're going to try to figure out these things.
Oh, Mr. Chair.
Yep.
Should we put, crap, like meters or centimeters or what?
A unit? Yeah,
Units,
okay.
that's
Yeah,
it.
sure. Pick a unit. What do you want?
Meters
Meters, okay.
Meters? No.
per second.
So that's meters.
Same for any more utilizers.
Cool. Okay. We can do doesn't really matter that much. Okay. Okay. We're going to start from the top and work our way down. So starting at purple. Okay. What distance did this object cover?
3 meters.
Actually, hang on. I've got to write all my list. Distance